So we just got off of proportional relationships and we were just introduced to the concept of y equals mx and then plus b. We got this new plus b involved. And we learned that that is our beginning value. We've been kind of learning everything in terms of story problems, which usually are not like our favorite thing to do. However, I do feel like it helps you learn about what that B actually means. So we learned that it was our beginning value. I gave you all kinds of story problems, meaning like you started with $25. That's what you began with, right? And then I said from there, you want to add to that. You're going to save $10 each week. And so you said that I am starting out and adding $10 each week to my savings, which before last week, this was me not having anything, but now I'm beginning with this amount. And so we are into the idea of shifting this proportional relationship up, right? So no longer are we starting at y equals 10x. We are starting with something to begin with, okay? Now, we're going to take a break from some word problems for a little bit, and we're just going to look at some little itty-bitty equations that look like maybe y equals 2x plus 1, or y equals 1/2 x minus 3. And we're going to kind of remove that real-world aspect to it today and just kind of zoom out a little bit and see what this is going to look like on a graph, okay? I mean, if we wanted to come up with some stories to go along with it, this could be I had one sucker and I'm collecting 2 each week. This could be I was $3 in the hole and I'm saving 50 cents a week, although we don't need to do that, okay? That's great to keep in mind, but I really kind of want to simplify this for a little bit. And so I want to take a closer look at this formula right here, my y equals mx plus b, and what I'm about to show you might be seriously one of the easiest things we do. And so if I were to give you an equation and say, hey, could you use this equation and identify the slope and the beginning value for me, please? And literally, if all I were to do is say, hey, what's the slope of this line? What's the beginning value of this line? You would look at this and say, well, the slope I've been learning about for weeks is the number in front of my x. That's 2. The slope in this line is 1/2. And my beginning value is going to be that new number that was added at the end of my proportional relationship. And in this case, it's 1. And in this case, it's -3. So I'm asking you to take a look at the equations that are given in slope-intercept form and identify the slope and the intercept, the y-intercept. Really, that's it. Now, sometimes they get a little crazy, like if I were to just say y equals 5x. Let's go back to proportional relationship here for a minute. If I were to say m and b here, you know that the m is your slope, which is the 5. If I asked you to fill in a b, a beginning value, back before you even knew what this b was, and we were saving money, my beginning value, if there was nothing there, was 0. So when you look at proportional relationships in terms of when we're getting ready to graph and you don't see that number after it, you know that my beginning value was 0 because that's the 0, 0 that we were so comfortable with during that whole week, right? This one might be a little bit different if there's no coefficient, like let's say +2. This one's a little different because if I say, okay, what is my slope? And this means I have $2 to begin with. So you know the number after goes here. And something we learned in combining like terms, if I asked you to take 4x and add x to it, you guys told me that the answer to that was 5x, right? Because when a variable does not have a visible coefficient, you know that it is an understood one. And so that's why you added and you got 4 plus 1 is 5. So the same rule applies here. We're still operating under the same assumption when I don't see a coefficient, like I saw a 5 here or a 2 here or a 1/2 here. When there's nothing there, you are to assume that the slope is 1, which means I had $2 and I'm saving 1 per week, okay? Now, sometimes things get a little unorganized. So if this is our slope-intercept form that we need it to be in, and sometimes it looks like this instead, and I ask you to identify the slope and the y-intercept. You got a little bit of work to do first. So, oh gosh, I don't know if you remember back to when we solved equations, like if I said, I'm thinking of a number, I add 5 to it, and I get 8. What number am I? Well, you wanted to get a by itself, right? And we learned about some properties that said if you have an equation and you need to cancel something out, you use something called the inverse operation, and you said, I need that 5 gone. And so you used the subtraction property of equality to cancel it out, right? This isn't too long ago, and that's how you showed me that that was 3. Well, we're going to use the same property with this. So let me rewrite this as I wrote right underneath it. I need a little bit of room, because if I need this to look like this, that means that the y has got to be all by itself. Nothing else can be on the side of the equation of the equal sign other than the y. And right now, this is in the way. And so the same concept that we used solving equations applies here. You're going to do the opposite of subtracting 3 and add 3. And the only thing that's going to be a little bit weird here is that when we went and subtracted 5 over here, we were able to combine like terms because 8 and -5 were like terms. I took care of that here, but when I go to do this here, I am not going to make this 5x, or at least I hope you're not, because you know enough to know that that is a 2x and this is a 3. These are not like terms. So what do? You just put it in slope-intercept form. You say, well, I can't combine these two, so I'm just going to rewrite them right next to each other. If you felt like getting a little crazy and you didn't want to put it like that, and you said, I'm going to put the 3 first and then the x, that's totally okay too. We don't see it this way too often, but it's good to, I guess, see it this way. So that when you do see it, we are more comfortable with the mx and then the b. If you have it this way, you just have to know, oh, I have $3 to start with, and I'm saving 2 per week, versus this way. It's the one that's with the x that is your slope. So now that I have officially taken and used this inverse property to solve for y, now I can easily identify that the m is the number in front of my x, which it doesn't matter what place it's in, it's 2. And the number that is going to be my b is the constant that's by itself, which in this case was 3. Now I need to point something out. A lot of kids may look at this and kind of forget to put it in slope-intercept form. And if that's the case, you might say that the b value is -3, but it's not. It's got to be solved for y first to get that. So if I were to say y plus 1 is equal to -1/2 x, and ask you what is the slope and what is the y-intercept, hopefully you would remember, oop, it's not in slope-intercept form. So let me just do that real quick. Let me cancel that out. Let me get my y by itself, and now I'm going to say, well, I'm going to go ahead. I like it when my x is on the left. And then I'm going to take that -1 and put it here, which means now it makes it very easy for me to see that my slope, something's decreasing by half, 50 cents, whatever you want to say, and my b value is -1. Okay, the only other thing that I really want to add to this is how you would, another way to name your ordered pair, and this is actually really, really important. Your b value is the value that you are going to begin at when we graph, and we're going to graph next. And so this is actually an ordered pair. And so it's called your y-intercept, right? Because your y-intercept means where this line, when I go to graph it next, is going to touch the y-axis at, right? And this one's the y-axis. It's like all these times it was touching the y-axis at this point. So So we go back to, I don't know if you remember when we graphed those little pumpkin things where we plotted a bunch of points and we connected them to make a picture. Well, hopefully you remember that if it was on the y-axis, the x movement, our horizontal movement, was 0. And so I'm going to take this 1 and put it here, because another way to say start at 1 on the y-axis is to say start at 0, 1, which this then would mean if I'm going to start at -3 on the y-axis, that means don't move left or right, but move down 3 and start at 0, -3. This one's easy because they're both 0. And this one means 0, 2. So if it's on the y-intercept, right? We call this our beginning value, but the technical term for it is y-intercept, right? And a y-intercept always, 1,000% of the time, which I know that's not even possible to have, always will have an x coefficient of 0. That will be 0 all the time. Every single time you are telling me where does it start on the y-axis? Well, it starts at 0, comma, and then whatever that number is. So down here, this one would be 0, 3. That's where I'm going to begin. This one here would be 0, -1. Okay? And so right now we just needed to be able to identify M and B from an equation.